Hello, welcome back. Okay, so 4.3, intersections of a line and a plane. Okay, now we got to comprehend something. We got to understand that a plane can have an infinite number of direction vectors, okay? And you need two of them to describe a plane. But a plane only has one unique normal, only one direction that is perpendicular to the plane. And so we're going to work with those normals, and they're going to help us figure out how a line and a plane could interact. Now, there's three main ways. The line and the plane may be parallel and distinct, meaning that the line is not in the plane, but that the direction vector of that line is parallel to the slant of the plane. Okay? Or we could have a plane and a line intersect so that they intersect at exactly one point. And we could have a line and a plane intersect such that the line actually lies in the plane that we're looking at, and we would then have an infinite number of points of intersection. So this is an infinite number of points of intersection. This is exactly one point of intersection, and this is no points of intersection. All right, so once we have that to contend with, the next thing we sort of want to think about is how can we classify these? Well, the first thing I want to do is go and put a normal on here. So let's say that I need a normal to this plane, and I'm going to put the normal to the plane. Oh, let's hope that this looks right when I do it. We'll put it there, and that is the normal to the plane. Okay? Now, notice that the normal to the plane is coming up to this line, and where would the direction vector of that line be? Well, the direction vector of that line, if we, I need another color here. Well, maybe black can do it. I just want to make it look pretty. I'm going to put the direction vector of the line, perhaps, is going like there. So you'll notice that the direction vector, okay, and this normal are actually at 90 degrees. And so this direction vector of the line and this normal would actually have a dot product of 0. Something to keep in mind. Over here, let's take a look at the normal of this plane. Well, there's my normal. And notice that the normal is perpendicular to the plane. And since the line is in the plane, then again, it's going to be perpendicular to any direction vector that I'm using from that line. So there's my direction vector. That direction vector is actually lying in the plane. And notice the difference between lying in the plane and lying above the plane would be similar to this. Maybe if I just take a piece of paper, and if I fold it so it's usable. Okay, here's my plane, and here's my line. And so if I look down on it, you'll notice that one is above the other, okay? And this would be parallel and distinct. Over here, the line would actually be in the plane, and it would actually be so that there's no distance between it. The line is actually in the plane. Now remember, what we're talking about are normals. So there's my normal to the plane, and if this was my line up here, you see how we get that 90 degrees. And if my line's down here, I get 90 degrees, or even if it's spun around, I still get 90 degrees between this direction vector and this normal. Okay, what's over here? Well, we're going to have a normal that's coming up out of the plane. Okay, now I don't have to put it here so that they're connecting to, the normal could have been over here, but what you can certainly see is that there's going to be an angle here. This is coming up out of the plane, so maybe if I take this and put a hole in it, let's see. Okay, so now I've got this. Okay, so it's off to a diagonal slant a little bit, trying to show that. So that's my line coming through. Where would the normal be? The normal would be coming up. Maybe I can zoom out a little bit. You know what? We're going to take it this way. We're going to bring it, oh, that's upside down. Let's not do that. We're going to bring you this way. I'm not sure if that's upside down. We're going to take a look at here. So here you have, oh, going the wrong way. I got to learn to move backwards. Okay. So here I have the normal. no, this will be the line going through the plane. Let's give it a little bit of a slant. So it's coming through slanty-like, and I'm going to put a normal up. Again, I have to learn to work backwards here. There's my normal, and it's going to have an angle between those that is not 90 degrees. And that would even be the case if it was parallel, not parallel, if it was, again, working backwards. I can't find the thing. Where is it? Here we go. Then even if they were collinear, the normal and the direction vector, they still don't have an angle of 90 degrees. They'd have an angle of either 0 or 180 degrees, and the cosine of that would be 1. So that also wouldn't give you a dot product of 0. So once again, let's bring this back. Let's get this set up. That is what we're looking at. We're going to try to examine planes and lines and how they can intersect with each other. Notice they can have no intersection. Notice that they can have one intersection, one point of intersection. Notice that they can have an infinite number of intersections. And please remember, we're talking about the intersection of this line. Let me grab of this line here and the plane, not with the normal. And we're talking about the intersection of this line here with the plane, and we're talking about the intersection, which there isn't any, of that line and this plane. And what we're going to come down to is looking at the normals. Notice that this normal dot the direction vector of the line will be 0. Notice that this normal of the plane dot the direction vector of the line will be 0 in both of those. And in this one, the dot product with the normal from the plane and the direction vector of the line, so here's direction vector of the line, there's my normal, is not going to be 0. So that's going to be one way that we can help to identify. The other way we'll be looking to see whether or not, so if we get this one, we have two possibilities, is looking to see whether or not we have any points of intersection, or if we have, in this case, no points of intersection, or if in fact we have an infinite number of points of intersection. That's your introduction. I'm going to stop here and then we'll do example A.